Today we will be doing the second session of the chapter Application of Derivatives. Suppose there is a graph which is decreasing to a minimum and then increasing, and let's say there is another graph which is increasing to a maximum and then decreasing. In this graph, you can see that if you take 3 points A, B and C, suppose, then at the point A, the tangent is making an obtuse angle. So at the point A, dy by dx is less than 0. Because the tangent is making an obtuse angle. And at the point C, the tangent is making an acute angle, so dy by dx is greater than 0. And at the point B, the tangent is horizontal, so dy by dx is equal to 0. So at the point A, dy by dx is less than 0, at the point C, dy by dx is greater than 0, and at the point B, dy by dx is equal to 0. You will notice one thing, that between A and B, the graph is decreasing. So that means for a decreasing function, the derivative is negative. For any decreasing function, the derivative will be negative. Now look at the portion from B to C. You will see that the graph is increasing, and in fact dy by dx is greater than 0. So that means for an increasing function, dy by dx is greater than 0. So for a decreasing function, dy by dx is less than 0. For an increasing function, dy by dx is greater than 0. Similarly, if you look at this graph, the tangent at A is making an acute angle. So between A and B, it's an increasing function, and you can see that dy by dx is coming greater than 0. And at the point B, the tangent is horizontal, so dy by dx is equal to 0. And at C, the tangent is making an obtuse angle, so dy by dx is less than 0. So from A to B, the graph is increasing, so dy by dx is greater than 0. From B to C, the graph is decreasing, so dy by dx is less than 0. So whenever a function is decreasing, the derivative is negative. Whenever a function is increasing, the derivative is positive. Now, when the derivative is 0, it is either a point of minimum or a point of maximum. So, at dy by dx equal to 0, we say that it is a point of maxima or minima. So whenever dy by dx is equal to 0, it's a point of either maxima or minima. Now you will notice one thing, that in this graph the derivative is changing from negative to 0 to positive. So the derivative is increasing. From negative it went to 0, from 0 it went to positive. So the derivative is increasing. That means the derivative of the derivative is positive. So whenever a function has got a minimum value, that means whenever there is a minima, the derivative of the derivative is positive, or rather the second order derivative is positive. Similarly, look at this graph. The derivative is changing from positive to 0 to negative. That means the derivative is decreasing. It is going from positive to 0 to negative. That means the derivative of the derivative is negative. So whenever the second order derivative is negative, then it's a point of maxima. So let us summarize this discussion. Whenever a function is decreasing, the derivative is negative. Whenever a function is increasing, the derivative is positive. If derivative is 0, it is a point of either maxima or minima. If the second order derivative is positive, it is minima. If the second order derivative is negative, it is maxima. Now, one very important thing has to be understood, that maxima or minima is a local phenomenon. So we often call it local maxima and local minima. It's a local phenomenon. Let's understand what it means. Suppose there is a function y is equal to x plus 1 by x. So the derivative is 1 minus 1 by x square. Suppose the derivative is 0. So you know that x is either 1 or minus 1. Now you differentiate dy by dx, so you will get 2 by x cube. So this is greater than 0 at x equal to 1. So that means that it is a point of minima, and it is less than 0 at x equal to minus 1. So that means that is a point of maxima. So in this particular question, we can easily see the derivative is 0 at these 2 points. At 1 it is minima, and at minus 1 it is maxima. Now if you graph this function, you will see that the graph will look like this. So in this graph, this particular point is a point of local minima, and this point is a point of local maxima. That means in the immediate neighborhood of this point, it is the lowest, so it is local minima. In the immediate neighborhood of this point, it is the highest, so it is local maxima. So you have to understand that local is different from global. Global minima in this graph will be minus infinity, because you can see the graph will go down to minus infinity. Global maxima will be positive infinity, because you can see the graph is going up to positive infinity. So it's very important to understand that the techniques of equating derivative to 0 and finding out the sign of second derivative, they basically give us the local minima or the local maxima. Now, in case we are dealing with standard functions like polynomials or sine or cosine functions, invariably the local is also the global. Suppose a question is given like this. Fx equal to x plus 1 whole cube into x minus 1 whole cube. So if you differentiate this, so the differentiation answer will be 3 into x plus 1 whole square into x minus 1 whole square into 2x. So you can easily see that in this particular question, if you equate the derivative to 0, then you will get x equal to 0 or 1 or minus 1. Now we are asked to investigate the intervals of increase and decrease. So we have to investigate the interval of increase and decrease. So we can say that when x is greater than 0, fx is increasing, and when x is less than 0, fx is decreasing. So this is a question. You are asked to find out the intervals of increase and decrease. So after doing the derivative, when x is greater than 0, it's increasing, and when x is less than 0, it is decreasing. Suppose there is a right angle triangle in which the angle between hypotenuse and base is theta. The question is, you have to prove that the area is maximum when theta is 60 degree. And by the way, you are told that hypotenuse plus base is constant. So L plus L cos theta is constant. Now you know that the area of this triangle will be half base into height. So instead of L square, you can write S by 1 plus cos theta whole square. So this is the expression for area. Now you find out dA by d theta. And equate it to 0. You find out dA by d theta and equate it to 0. So you will get you will get, if you take 1 plus cos theta common, cos 2 theta plus cos 2 theta cos theta plus sin 2 theta sin theta 0. So you will get cos 2 theta plus cos theta 0 . So 2 cos square theta plus cos theta minus 1 is 0. So 2 cos square theta plus 2 cos theta minus 1 is 0. So cos theta is either half or minus 1. So we got derivative of area with respect to theta 0 when cos theta is either half or minus 1. So dA by d theta the expression is this. This is the expression for dA by d theta. So 2 into 1 plus cos theta whole cube into dA by d theta is s square into cos 2 theta plus cos theta. So if you differentiate it again, then this part will become 0 because dA by d theta is 0. This part will be positive and the right hand side is negative. So second order derivative will come negative. So that means the area is maximum when cos theta is half, which means theta is 60 degree. So that brings us to an end of this question, and it also ends the session of application of derivatives.